So this is Geometry, Semester 1. It's a unit on probability. This is the third lesson, and it's called Rat Maze Practice. It's on CreatorMathcom under the Geometry tab. And you might have to Google CreatorMath.weebly.com to find the site. So the instructions are: copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from CreatorMath.com. I always, or at least most of the time, try to model that for you right here. Here's the name of the website, CreatorMath.weebly.com. Google that. You should get to the home page, which looks like this. Right? Any questions on the composition book, you guys? I try to say this every single video, so if you're watching them, you're sick of it. If you're not, then this would be the first time you saw it, possibly. So everything for the comp book is underneath this picture. Scroll down until you see the large words composition book and the picture. Read all the instructions, watch all the videos, follow all the due dates, and put everything where it belongs. All right? If you do that, you should have a 90 to 100% on your comp book. Now, when it comes to notes, we're going to go to the tab for your class, and in this case, it's geometry. So the tab for the class has all of the actual notes, the video lessons, the problem sets, and of course the vocabulary. So here's a PDF, Vocabulary Geometry Practice Study PDF. It's an entire list of all the vocabulary words you will use for the entire school year, and it is searchable, you guys. If you're not getting 100% on your vocabulary practices, then I encourage you to please figure out how to use this vocabulary study PDF, because it's got them all on there and it is searchable. Download this to your device and then Google how do I search a PDF on whatever kind of device you're using and follow those directions. Each device is a little bit different. So we're going to find the semester that this video is for. That's very important, because if we're in the wrong semester, it'll be awfully hard to find. So this one happens to be from semester 1. This is the table of contents. You should have already copied this entire table of contents on the pages 2 through 6 of your composition book. If you haven't done it already, please go back, watch all the videos on the comp book, and do as it says. Number the pages and fill in the table of contents, etc. Now I'm going to find the unit we're in, which is statistics, or here, probability and statistics. It's called probability. There are 1, 2, 3 lessons. We're on the third lesson called Rat Maze, if I could talk. And this goes, these notes that we're going to look at go on these pages of your composition book. Please don't take this video's word for it, but go back and find the original table of contents. At the time you're watching this video, these page numbers probably will have changed. Here are the notes. Here are the problem set we're going to do, and the video solution will be tagged here or linked here once it's done. We're going to click Notes. Fair warning, it can take a couple times to open these for me, so probably for you, same experience. Once it brightens up like that, I can enlarge it. I'm going to copy all these notes right on into my composition book. This explains the rat maze, and I'm going to do most of this right now while solving these problems. Some of the things from vocabulary that are probably important for right now are probability. The percent chance of an occurrence or event can be expressed in percent or does it say fraction or fraction? In percent or fraction, all right? That's the struggle you guys go through, so I just went through it right there. Event and outcome, right? Random. An equal chance all outcome of all outcome options, right? Percent. From percentum, which literally translates to per 100 or out of 100. Notation, P of E right here. I would like to say E or C in this case. So P of C is the probability of an event C occurring. So we name the event C, and the probability stands here. This notation reads probability of event C occurring. All right, so put these in your comp book. They're going to help you move through these practice problems, and we're going to show you how to solve them right now to the best of our ability. So this is a sort of a famous construct. It's a rat maze. And the idea is tunnels that the rat can run down randomly. All right, so we're assuming that the rat can run down these tunnels randomly, and I'm filling in the solid areas. The tunnel can't run through these things I'm coloring in. So that leaves, it's easier to see now the tunnels. The rat could run down this tunnel. The rat could run down. The rat's running from left to right. down these tunnels and ending up at different points here, and we're going to examine the probability that the rat will reach each, assuming that the rat has a completely random ability to run down the different tunnels. We're going to neglect the smell of food or anything else that would be in real life a changing factor to the probability, and just stick with pure probability for now, because we need to learn probability concepts first. Then we can go in and muck it up with, even if the probability is this, there's probably other factors that make it more or less likely. Okay, so given the following rat trail, what is the probability a rat will take path A, B, or C? So I always try to draw a rat for you guys, and it looks like this. This is my rat. So the rat's here. What's the probability they go down tunnel A, B, or C? Well, since there's 3 tunnels, it's 1/3, 1/3, 1/3. All right? The other way you could take it percent would be 33.33%, 33.33%, 33.33%. Because there's a 100% chance they're going down one of these. They have to come out of 100%. So you can do probability either on a percentage basis, which is out of 100, or you can do it on a fraction basis, which is out of 1.0. Right? 1/3, 1/3, 1/3 adds up to 1. Okay, so that's the idea. It's going to run down one of these 3 tunnels. So now you see kind of where we're headed. Let's do a couple more. I'm having a hard time fitting these in. Can I get this up maybe? Okay, that's a little better. So, given the following rat trail, assuming the rat has gone down A, what is the probability a rat will take D or E? So now, the rat has already gone down tunnel A here. So now let's draw the rat here. All right, that's my best rat, you guys. What's the probability they're going to go down D or E? Well, there's only 2 options, so it's 50-50, 1/2, 1/2, or 50%, 50%. All those ways are expressing, and probably pretty understandable to students. Students might say 50-50 chance, right? That means, you could go either way. It's like flipping a coin. If there's only 2, like a coin has 2 sides, so that makes sense for 50% chance. It's got to end up on 1. I don't know the last time anybody's flipped a coin and it ended up standing on its side, although probably it has happened. All right. All right, given the following rat trail, assuming a rat has gone down C. So now we're assuming the rat's gone down C here. What is the probability they'll take F or G? Well, there's 2 options, F or G. Here's our rat right here again. All right. Will the rat go down F or G? 50-50, 1/2, 1/2. Very simple presentation to help us sort of understand what are the chances. But it gets more complicated, and we'll see that in a minute. Given the following rat trail, assuming a rat has gone down G. So where are we? Oh, we've gone all the way down C, G. Now we're sitting here. What is the probability a rat will go down H, I, or J? So H, I, or J. H, I, or J. 3 options, so 1/3, 1/3, 1/3. You're seeing where this is headed. If there were 4 options, it would be 1/4, 1/4, 1/4, 1/4, right? All right, so this problem I already started to modify right here. Given the following rat trail, what is the probability a rat will take path D? So, first of all, I'd like this hint. This hint says hint, and multiply, and or add. You can see it down here, this hint that I would like up at this question too. And I'm going to move it there, and I'll change it for you by the time you see it. What's happening here is we're asking, we're not saying assuming the rat went down A. Assuming the rat's back here, all right, what is the probability they'll take path D? That means they've gone through A and they're going down D. Well, what's the probability of A? We already said it was 1/3, right? What's the probability of D? We already said it was 1/2. So now the rat's going to end up here, right? What's the probability the rat ends up right here? You've got 2 probabilities. It has to pass through a probability of A, and it has to pass through a probability of D. So that's why I wanted the hint here, because and means multiply. That's your hint. Because we had to pass through A and D, we have to take A and multiply it by D. And means multiply is your hint. Multiply across the numerators, 1. Multiply across the denominators, 6. 1/6. And it's 1/3 times 1/2 is 1/6. And if you notice, multiplying fractions is way easier than adding fractions. Remember, with adding fractions, we have to find a common denominator. With multiplying, we just go straight across the numerator and straight across the denominator. Right? Okay, given the following rat trail, what is the probability that we will reach K? So where is K? Here's K here, you guys. So the rat is now starting here and going all the way to K. And they were kind enough to call out the different probabilities at each juncture, right? But because the rat has to go through 1/3 and 1/2, it's multiply. And is multiply. 1/3, 1/2, and 1/3. We're going to multiply 3 fractions, no problem. Multiplying is easy. 1 times 1 is 1. 3 times 2 is 6. 2 times 3 is, 3 times 2 is 6. 6 times 3 is 18. 1/18th chance of ending up at K. And notice how 1/18th is a smaller number, right? It's a smaller number because the rat could have gone to these two, right? That would have taken it out of this loop. And then down here, the rat could have gone to this one. That makes it less likely it's going to get here. And then here, the rat could have gone 2 other places. That makes it way less likely it's going to get here. By the time you compute that probability, and in this case, because it's and you multiply, it's only a 1/18th chance it's going to end up down at K. Pretty cool. And if you were thinking of sports or betting or gambling or anything else like this, right? You're trying to build probabilities that something would happen. What's the probability of one team or another ending up someplace? Well, you're trying to calculate what are the probabilities along the route to that and seeing if you can now come up with a probability at that juncture. All right, so given the following rat trail, what is the probability a rat will reach L? Where's L? Here's L. So rat's going down here, 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 okay? 1/3, 1/2, 1/3, 1/3, 1/2, 1/3. Remember the hint, it's and. It has to go here, and here, and here, right? It's not or, it's and. So and means multiply. So same thing we just did. 3 times 2 is 6, 6 times 3 is 18. 1 times 1 times 1 is 1, 1/18th. Given the following rat trail, what is the probability a rat will reach M? There we go. 1/3 and 1/2 and 1/3. And means multiply. 1/3 times 1/2 times 1/3. We've already calculated it twice. It's 1/18th. And so to reach K, L, or M are all the same probability of reaching there, right? All right, given the following rat trail, what is the probability a rat will reach N? So here's N. So where does the rat have to go? Here's the rat here, going here, here to reach N, right? So yeah, the rat has to pass through 1/3 and 1/2. So and means multiply. There's only 2 fractions. 1 times 1 is 1. 3 times 2 is 6. It's a 1/6 probability that we're going to reach N, that our rat is going to reach N. Given the following rat trail, what is the probability a rat will reach O? Okay, this is interesting. So before we're always coming down through this tunnel, right? Now we go straight, so here's our rat here, right? We go straight this way. Boom. Do we pass through any, there's only one probability, it's 1/3. There's nothing to compute here, it's just 1/3. Now I want you to remember something, this is 1/3 now, right? This was what do we say? This was 1/6, and these were all 1/18th, right? So I want you to look at this. It's a higher probability, 33% chance the rat's going to go down O. It's a much more likely proposition that the rat will get to O than will get to these others, especially these at 1/18th. A little bit higher here at 1/6, so it might get to N, but O is now by far the highest probability of being reached. So if we were betting on these, right, and we could figure out these probabilities of the bet, we would definitely bet on the rat reaching O because there's a 33% chance of getting there. Okay? All right, given the following rat trail, what's the probability we'll reach P? So here's P. For P, we'd have to go up here and here. 1/3 and 1/2, and means multiply. 1/3 times 1/2 is 1/6. I'd still be betting on O, right? Because it's your highest probability of reaching at 1/3. Given the following rat trail, what is the probability the rat will reach Q? Okay, here's Q. So the rat's coming through these two. 1/3 times 1/2, 1/6. Again, I'm still betting on O. It's a lot higher than 1/6. Probability, that is, a lot higher probability. Given the following rat trail, what is the probability a rat will reach R? Okay, so Now we just jumped an energy level here. We're going to reach R. Let's think about this. Can the rat go through here? Yes, that's reaching R. Can the rat go through here? Yes, that's reaching R. Can the rat go through here? Yes, that's reaching R. Can the rat go through here? Yes, that's reaching R. So let me try to put this into context. There's 4 different paths that the rat could take to get there. So let me say this to you one more time a different way. The rat can reach R by going this path, or the rat can reach R by going this path, or the rat can reach R by going this path, or the rat can reach R by going this path. What word am I using? I'm using the word or. Or means add. I'm going to add this probability, all these probabilities together. I'm going to add 1/6 plus 1/3 plus 1/6 plus 1/18. Now we get back to a common denominator. Now we get back to a challenge for students going back to the 4th or 5th or whenever you started learning how to add fractions. Maybe even the 3rd nowadays. I'm not sure grade. All right, what's a common denominator? 18 works for all these. So we're going to start with 18. That stays 1 because it doesn't change. How many times? And we're going to put 18 under all these. How many times does 6 go into 18? 3. 3 times 1 is 3. How many times does 3 go into 18? 6. 6 times 1 is 6. How many times 6 go into 18? We already said 3. 3 times 1 is 3. So now we have the same common denominator. We know it's going to be over 18, and we're going to add 6 plus 3 is 9, plus 3 is 12, plus 1 is 13. So we have 13 over 18. That's the chance now that we're going to get to R, because we get to add those. So here we are adding them all, and here we are at 13 18ths. Right? So this was an or. The rat could go this way, or that way, or that way, or that way. Right? Because it's or, we add. And that's my hint for you. And is multiply, or is add. Given the following rat trail, what is the probability a rat will reach S? So here we are, S. Wow. So how can the rat get to S? Here's one. Right? Or down here. Or down here. Right? So since these are ors, we're going to add them. We have the final calculations here for these 3. We don't have to go back and recalculate. They're giving us these final ones, right? Which could be a little confusing, but that's what they are. We already did them ourselves. 1/6 plus 1/18 plus 1/18. Again, we need a common denominator. 18 looks like it's going to work. This one stays 1/18. This one is 1/18. This one stays 1/18. This is 3. 3 times 1 is 3. 3, 4, 5. This equals 5 over 18. This one here. And we can check the actual calculations. Even if we couldn't add up 5 over 18, we might be able to see that we can add this up. Oh, they give us the same for all. But these are out because they multiply, right? So a little bit tricky here, but not too tricky. We cannot simplify 5 over 18. Okay, so that's a rat maze for lesson number 3 of the unit on probability. Make sure you're matching up this title of this video with the practice set that you're doing. This is Geometry Semester 1. It's a unit called Probability, and it is the 3rd lesson called Rat Maze Practice. It's on CreatorMathcom under the Geometry tab. Hope that helps.